Solving equations with variables on both sides is very similar to solving multi-step equations. It's just a tad bit different. So the first example we are going to look at is 24 minus 3m equals 3m. With these types of problems, it's very important for you to draw in your algebra wall. Remember, your algebra wall is separating the two sides down by where the equal to sign is. So I have 24 minus 3m on one side, and I have 5m on the other side. The difference from what we've seen before is that this has an m on the left and it has an m on the right. When this happens, your main goal is to get every m or every variable on one side first. My hint to you is to always move the smaller one to avoid negatives. So since negative 3 is smaller than positive 5, I'm going to work on moving negative 3m over to the other side. So to do this, I'm just going to do the opposite of negative 3m. The opposite of negative 3m is to add 3m to both sides. When I do this, I have 24 equals 8m. This negative 3m and 3m have canceled. Now I'm just back to my one-step equation. I have 8 times m, so the opposite is to divide 8 on both sides. So m is equal to 3. These are very easy to check, again, because you just have to plug it in. If I plug this in, I have 24 minus 3 times 3 should equal 5 times 3. Well, is 24 minus 9 equal to 15? Yes, it is, so it works. My next example is very similar. I have 4c minus 7 equals 20 plus c. So my first step is to draw in my algebra wall. Now remember, c is the same thing as having 1c. There's that imaginary 1 in front. So 1 is smaller than 4, so I'm going to actually move 1c over. To do that, this is positive 1c, so I'm going to subtract c on both sides. Remember, you can only add and subtract things from its like term. So 4c and c are like terms. 4c minus c is 3c. And on the right, c minus c cancels out. Now I'm just back to my two-step equation. I'm going to add 7 on both sides. So 3c equals 27. And I'm going to divide 3. So c equals 9. My next example is very similar again, except this time we're bringing back the parentheses. I'm going to start by drawing in my algebra wall, and before I move anything over, I need to take care of those parentheses. So I'm going to distribute the 5. 5 times a is 5a. 5 times negative 3 is negative 15. The left side is just going to stay exactly how it was, 3 minus 4a. Now, for my a's, I have negative 4a and I have 5a. Negative 4a is smaller than 5a, so I'm going to add 4a to both sides. Remember, it can only add to its like term, which is 5a. So negative 4a and 4a cancel on the left, and I'm left with 3. On the right, 5a plus 4a is 9a, and I'm back to my two-step equation. I'm going to add 15 to both sides, and we have 18 equals 9a, and then I'm going to divide the 9 out, and we get that a is 2. Remember, you can always plug your answer back in to make sure it works. The next one I'm going to do has a fraction involved, and it's going to follow the similar rule that we used for fractions in multi-step equations. So the very first thing I want to do is get rid of my fraction. I'm going to do this by multiplying both sides by my denominator. So I'm going to multiply the left by 2, and I'm going to multiply the right by 2. What happens when you do this is the 2 actually cancels. I'm multiplying this whole term by 2. So the 2's cancel, and I'm left with 4m minus 6. On the right, 2 times m is 2m. Now, I've told you that I always move the smaller one, so I am going to do that this time. but a lot of people will go ahead and move the 4m over since 2m is by itself over here. Either way, you're going to get the correct answer. So I'm going to subtract 2m here because I also want to make a point of what happens when everything cancels out. When everything cancels out like this, 2m minus 2m, you are actually left with 0. On the left, I have 4m minus 2m, which is 2m, and then I bring down the minus 6. So from here, I have my two-step equation, and 0 is a number just like any other number. I'm just going to add 6 to both sides, and then I'm going to divide the 2. So m equals 3. My last example still has a fraction, but it looks a little different. I have 1/2 of x plus 2 equals 5x minus 8. On this one, I'm still going to multiply by the denominator. I'm still multiplying this side by 2. But what you have to be careful of is that you are multiplying this whole side by 2. We're not just multiplying 5 by 2, and we're not just multiplying 8 by 2. We are multiplying both 5x and negative 8 by 2. So this would become 2 times 5x is 10x, and 2 times negative 8 is negative 16. That's my right side. On my left side, the 2 times 1/2 cancels, and I'm left with x plus 2. Now, x is smaller than 10x, so I'm going to subtract x from both sides, and I'm left with 2 equals 9x minus 16. I'm going to add the 16 to both sides, and we have 18 equals 9x. Divide the 9, and we get x equals 2.